Hello everyone, myself Vedan and I am here to explain a Python code which is used to implement QR decomposition using Gram Schmidt process. So first we will see what is QR decomposition. The QR decomposition of a matrix A is a factorization of its QR when an orthogonal matrix its columns are orthogonal, meaning they are orthogonal unique vectors, or is an upper triangle matrix, that is a matrix where all entries belong, the diagonals are 0. The Gram Schmidt process is one way of constructing the matrix Q by orthogonalizing the columns of a Q. R is obtained from the projections of n into the various vectors in Q. Well, we'll go to the explanation of the code. Step, we have to define a function into the variables. So first, four codes of the line, that is def QR decomposition of a equals to do a shape. These four lines means that the function QR decomposition takes a matrix as a n and m and the number of rows and columns of a respectively. Q is initialized as the empty matrix, that is of. For strong, the orthogonal vectors U in another empty matrix used to store intermediate vectors used during the Gram Schmidt process. We have to start the Gram Schmidt process, that is second step. So the first columns become the first vector u1. The vector is normalized dividing by its norm. The first orthogonal vector qr in the vector capital Q. Third step is that we have to orthogonalize of a remaining vectors. So next set of goals, we have to run a loop for each subsequent column of the matrix, and the code starts by assuming that the current column, that is of a candidate for the orthogonal basics of the vector for the j in the range of loop. Subtract the projections of n onto all previous columns of q, efficiently removing components of that are in the directions of already computed orthogonal vectors. Once the project components are remove the resulting vectors ui in the orthogonal of the previous columns. The vector is then normalized to produce next orthonormal column in Q. In the fourth step, that we have to perform that constructing the upper triangular matrix R. Here R is capital R is initialized as the matrix of the same dimensions as each entry is calculated as the dot of columns of A and R. The loop for loop, that is I for range n for j in range and 1 comma m for this loop ensures that R is triangular because it only computes values of R I comma j when j greater than or equal to I. So the fifth step, that we have to print the results, that is print q and r. These two statements are used to print the results after the loops are done on the orthogonal matrix Q and the upper triangular matrix R and printed. Thus the QR decomposition is successfully done by using Gram Schmidt process. Thank you.